Good day, everybody. I'm back again. This is Dr. Nandi, your stat tutor. Thanks for watching. Today we will talk about confidence interval for standard deviation, how to calculate confidence interval for standard deviation. So without further ado, I'll share my screen with you. So the problem is a researcher claims that the standard deviation of the number of aircraft stolen each year is less than 15. In order to test this claim, a random sample of 12 years was selected, and it was found that the standard deviation of the number of aircraft stolen was 13.6. Using alpha is equal to 0.05, can we support the researcher's claim? So the null hypothesis is sigma equal to 15. So the hypothesized standard deviation value is 15. The alternate hypothesis is the claim sigma less than 15. Here, sigma is the population standard deviation. The data that we have been given is sample size n equal to 12. Standard deviation is 13.6. Alpha is the level of significance. Its maximum probability of rejecting 80 when it is true is 0.05. C level, the confidence level is 1 minus alpha. 1 minus 0.05 is 0.95. In order to solve this problem, we have to use ChiSquare Table. I have given the web address that I found on the web, which lists all the ChiSquare Table. Okay, you can use this link, or you can use another link, or you can use the textbook if you have a ChiSquare Table available in your textbook. The table that I have used is the link I have used. I got the table from there. In the table, chi-square values are given for different degrees of freedom. Now, degrees of freedom is sample size minus 1, df. N minus 1 is 12 minus 1 is 11. In this table, df values are in the first column, and the areas across the top row are the areas to the right of the critical values of chi-square. When we want to determine the confidence interval of standard deviation, we have to use a chi-square chart, which comes from this chi-square distribution, which you see on the screen. And I told that in the table, on the top row, the areas across the top row are the areas to the right of the critical value of chi-square. So for confidence interval of 0.95, area under the chi-square distribution is 0.95 in the center. Much like we do for confidence interval calculation for the mean, area in the center of the distribution is 0.95. Same concept here. Areas in the center of the chi-square distribution is 0.95. That is my confidence level of 95%. So areas in the two tail, the remaining is alpha, which is 0.05. That is equally distributed in the two tails of the distribution. So area of the left tail is 0.025, and area of the right tail is also 0.025. Notice I have indicated two chi-square on the horizontal axis. These are the critical values. One on the left is known as chi-square left, and one on the right is known as chi-square right. As I told before, the area on the top row of the table are the areas to the right of the chi-square critical values. So for chi-square left, area under the curve to the right of chi-square left is 0.95 plus 0.025 in the right tail. It's 0.975. And area to the right of the other critical value, chi-square right, is only 0.025. I already discussed that my degrees of freedom is 11. We will focus on the area 0.975 and the area 0.025 in the top row. First, I will find chi-square left, and then I will find chi-square right. Chi-square left is 3.816 for degrees of freedom 11, and chi-square right is 21.920. This comes from inside the table that I have referred in the top. So the 95% confidence interval for sigma square is the variance square of the standard deviation, is n minus 1, sample size minus 1, multiplied by sample variance S square divided by chi-square right. This is the lower boundary of the confidence interval for the variance, and the right boundary or the upper boundary of the confidence interval for chi-square is n minus 1 times S square divided by chi-square left. So in our case, degrees of freedom is 11 multiplied by standard deviation square is 13.6 square divided by chi-square right is 21.92. That is the lower boundary of the confidence interval for sigma square, and the upper boundary for the confidence interval for sigma square is 11 multiplied by sample variance, which is 13.6 square divided by chi-square left, which is 3.816. If we do, so in our calculator, we will do like this: 11 multiplied by 13.6, and then we will press the X square button, which is in the first column, first left column of the calculator, halfway down in the center is X square. Press that after 13.6. So we'll get the exponent 2 on top of 13.6 and then divide it by 21.92. That will result in the lower boundary for variance as 92.82. Similarly, the upper boundary for the 95% confidence interval for variance is 562.25. Now we know the standard deviation is the square root of the variance. So we will take the square root of the lower boundary of the variance, and we'll take the square root of the upper boundary of variance, and we'll take the square root of sigma square. And in that case, we get the result: the lower boundary of the 95% confidence interval for the standard deviation in this case is 9.63, and the upper boundary of the 95% confidence interval for the standard deviation is 23.71. Okay, that is, with 95% confidence, we can state that the actual value of the standard deviation will fall between 9.63 and 23.71. Remember, our null hypothesis was sigma equal to 15 and alternate is sigma less than 15. So the hypothesized value of standard deviation is 15. Now our 95% confidence interval runs from 9.63 to 23.71. 95% confidence interval for the value of sigma. Notice the hypothesized value of sigma equal to 15 is inside this interval. Hence the decision: do not reject 80. Okay, because the hypothesized value of the standard deviation 15 is inside the 95% confidence interval, we do not reject 80. Okay. If you have any question, please type a comment and I will respond. Please subscribe to my channel because I come back every week with new statistics problems and show you how to solve those with TI-84 in less than 10 minutes. Okay, please subscribe to my channel, and thanks for listening and have a good day. Okay, see you.